Hello, students, and welcome to our topic, organic chemistry. We've got a lot to cover over the next couple days, and so let's get going right away. Open your books if you haven't done so already, and let's dive into organic chemistry. As you have already heard and learned from our introductory videos yesterday, the word organic is part of the word organic chemistry. Big surprise there. Wow, lights went off for a moment. But we are talking about organic chemistry, having the word organic in the name. When you hear the word organic, you might think of things like all natural or no chemicals or grown on a farm and what have you. In marketing terms, organic takes on all sorts of meanings. But in chemistry, and in particular organic chemistry, originally got its name from the fact that organic molecules came from living things. Now, today, we're able to synthesize or manufacture organic chemicals without relying on living things, but that's a story for another day. The bottom line is, over 100 years ago, when organic chemistry first came on the scene, it was based on the fact that the kinds of compounds that were discovered were only found in or from living things. So when we talk about organic chemistry, there are a few main points that I want to make throughout this week. And one of them has to do with the element carbon. We are carbon-based organisms. In fact, all living things on planet Earth, as far as we know, have carbon, the element carbon, in them. And carbon is a fundamental element in the structure of all living things. As we seek out new worlds and new civilizations, as we explore Mars and beyond, we are investigating these other places in our own solar system for compounds that contain carbon in them, because that's what we know as life. But perhaps someday we will discover other life forms on other planets that might be based on other things like silicon. This is actually a picture out of a Star Trek episode where Captain Kirk is battling with an organism that is based not on carbon, but on silicon, believe it or not. In fact, I just watched that episode over the weekend to remind myself about what in the world that blob was. But it was a silicon-based organism. But as far as we know in science and real life, all living things, at least here on planet Earth, are carbon-based organisms, which is really fundamental, because as we study this week organic chemistry, we're going to be talking about organic compounds, how they are made, how they are structured, how we identify them, and what we name them, and other things. But carbon, again, is fundamental. Circle the word carbon in your notes, because carbon is one of those fundamental things in organic chemistry. Now, this funky model that you see illustrated here is kind of like some of the funky models we're going to be playing around with here in chemistry this week. And we're going to be playing around with these models in order to help us understand how these organic molecules are put together and how they function. So again, important point, and I know I keep emphasizing it here, but I want you to look at this cartoon as well. Carbon, compounds containing carbon is what organic chemistry is really all about. And look at this cartoon. How many hands does this carbon symbol possess? Just yell it out. Yeah. 4. Why do I have this cartoon of a picture of a carbon symbol with 4 hands? Think about it for a moment and raise one of your hands if you can tell me why or what the significance is of this cartoon and carbon, because this is the next fundamental truth and basic foundational information when it comes to organic chemistry. All right, if you said that carbon has 4 valence electrons and it's in group 4A, you're absolutely right. And this property, characteristic, or identity of carbon is what enables organic compounds to have such great diversity and variety. In fact, it was mentioned in the video that you saw yesterday, there are over 16 million different kinds of organic molecules, and it's primarily because of that magic number 4 with carbon. Carbon having 4 valence electrons affects the way it bonds with other things, in particular hydrogen, but other elements as well. You see, carbon is incredibly friendly. Have any of you ever known a social butterfly? Somebody who's just so easy to talk with or listen to or talk to? And they have such a wonderful personality, they could get along with anybody. Well, that's kind of like the element carbon. Carbon is just so friendly because of its 4 valence electrons. You can see why carbon is involved in the production of so many different compounds. By the way, this probably looks like just gobbledygook to you, but I can guarantee you that by the end of this week, you will be able to look at this and actually understand what all of this gobbledygook looks, what it's there for, what it means. This is going to be easy peasy lemon squeezy by the end of tomorrow. Believe it or not. Okay. So, in order to truly understand how organic chemistry works, we've got to talk about carbon bonding. We've already established the fact that carbon has how many valence electrons? 4 valence electrons. And that is, again, so vitally important in understanding how carbon bonds with other carbon atoms and other elements as well. So we're going to be coming back to this later on because it may just look like a bunch of gobbledygook to you right now. But by the time we're finished with the lesson, this will all make much more sense to you. But first, again, a few basic principles. I know I keep saying it over and over, but I can't emphasize how important this is. Carbon bonds very readily. It is a super friendly element. So carbon bonds readily with other things, and there again is a great variety and diversity in the way in which carbon bonds, including that whole buckyball thing we talked about yesterday. Next, carbon forms covalent bonds. Think about last unit. We learned about the different types of bonds: ionic, covalent, and metallic. Well, carbon forms covalent bonds. I wonder if any of you remember what covalent means. If you recall, ionic bonds involve the transfer of electrons to form 2 ions of different charges, and that's what attracted them. Metallic bonds, the electrons are involved in a sea of electrons swarming around various nuclei, and that's what holds metals together. But what are covalent bonds? Raise your hand if you remember what covalent bonds are. Hopefully, you remember that covalent bonds are those that share electrons, covalent, like cooperation. The prefix co means sharing. So here we have carbons sharing valence electrons, and it's this sharing of valence electrons that make them so versatile. And as we said before, and again, I know I keep repeating myself, but it's just so important. Excuse me. I'm getting all choked up here. And I get the hiccups from being so excited about this next point that carbon has four valence electrons. And again, we're going to be emphasizing this all week long. It's those four valence electrons that open up a world of organic chemistry. And by the way, if any of you get the question wrong on the quiz about four valence electrons and carbon being such a happy element, I don't know what I'm going to do because I can't emphasize it more than I already am. So, a couple key points here for you to remember right now. Carbon bonds readily, it forms covalent bonds, and carbon has four valence electrons. And for the time being, I am going to say bye bye for now, but we'll be back soon.